Now we will study about the characteristics of metals, insulators and semiconductors on the basis of energy band theory. Already we know on the basis of your resistivity, metals have low resistivity, insulators have very high resistivity and semiconductors have the resistivity in between the metals and semiconductors. But here we will discuss or we will differentiate them on the basis of energy band theory. Already in the chapter of atoms or structure of atom, we know what is valence band and conduction band. So only we have to discuss about the qualitative idea. So in case of your metals, suppose this is valence band and this is conduction band. But in metals, there are two possibilities. Here, the valence band and the conduction band overlap with each other, or we can say here the energy gap. Energy gap means the forbidden energy gap is equal to 0. Another situation that is here the conduction band is partially filled and the valence band is partially empty. Remember, the energy gap or the forbidden energy gap between your valence band and conduction band is 0. That means in metals we know the resistance or the resistivity is very low, so that the electrons can flow easily or current can pass through the conductor easily. But in case of here insulators, insulator means at that time no electrons will jump from the valence band to the conduction band. Or in other words, we can say if the energy gap will very large, then the electrons are not able to move. But in semiconductor, the energy gap lies between your metals and insulators. Means in case of your semiconductors, the energy gap will very small as compared to your insulator. Now we will draw for the insulator. Suppose this is your valence band and this is your conduction band. Then the energy gap means Eg or the forbidden energy gap will very large. Means energy gap will be greater than here 3 electron volt, so that no electron will transfer from the valence band to the conduction band. But in case of your semiconductor, this is your valence band and this is the conduction band and this is the energy gap. Now this energy gap will be small as compared to the insulator. That means we can write down energy gap will be less than your 3 electron volt. Here, if we will say about your absolute zero temperature, then what will happen? At absolute zero temperature, the electrons which are present in the valence band have not sufficient energy, so they are not able to jump from the valence band to the conduction band. Or you can say at the time the energy gap will less as compared to a semiconductor, or at absolute zero temperature the semiconductor will act like a insulators. So this is all about your energy band theory for metals, insulators and semiconductors.